The content of this presentation is introduction, part drawing, assembly drawing, exploded view, and part list. The last one is conclusion. Next, we're going to introduction. Autodesk Inventor is a computer-aided design extension application for 3D mechanical design, simulation, visualization, and documentation developed by Autodesk. Allow analyzing 2D and 3D CAD models by creating a virtual representation of the final product in order to validate the form, fit, and functioning before build. Support parametric, direct edit, free-form modeling, part modeling, and assembly modeling. It provides support for various CAD format and standard DWG drawings.
Good day, everyone. Today I'm presenting my design for a secure extension socket model and assemble using Autodesk Inventor 2026. This project consists of 10 unique components which I have organized into this exploded view to demonstrate the internal mechanic and assembly flow. Uh, the first thing is how I the top cover, how I made it. I started with the top cover which served as a primary housing. I began with a 2D sketch of the outer diameter and used the extrude command to create the base volume. The tools and technique I use is to create the internal cavity. I use the shell tool with a 2 mm thickness. I then apply the fillet tool to the exterior edge to ensure a smooth ergonomic finish for the socket seating. I use an extruded cut to create a precise rectangular opening you see here. Alright, that's it. Thank you.
So, for the socket, it is designed by a 2-point rectangle which has a thickness of 8 mm and 85 nm long. The socket holes is the width is 5 mm and the long is 8 mm. For the screw holes, it has a diameter of 3. For the switch, it is designed rectangular, and then it is cut into a right angle triangle. Then it is filled with a radius of 2. It has a long width of 17 mm, a width of 11 mm.
Hello, everybody. My name is Sudiaki Cyril, and I will continue our presentation with the parts that I create, which is the first one, the screw. The screw are the primary fastener that holds the internal assembly to the top cover. Since these are standard components, I focus on precision for the threads and the head type. The tools and technique that I use, I use revolve command to create the screw body and head profile. For the technical detail, I use the thread tool to apply standard metric specification. To create the cross for the screwdriver, I use a sketch on the top face followed by an extruded cut. Because there are two screws, as seen in the quantity list, I use the pattern tool in the assembly environment to ensure they were spaced perfectly apart without having to constrain them individually. The second parts that I create, the lower cover. So the lower cover acts as the base of the extension. It needs to align perfectly with the top cover to seal the unit. The tools and technique is similar to the top. I use extrude and shell. However, I use the project geometry tool to pull the dimensions from the top cover into my new sketch. This ensures the diameter match exactly. I also use the hole tool to create the center point where the spool exit sits. I manage the fit by using a lip and groove style design, ensuring the wall thickness of the base fits just inside the top cover for secure snap fit. Okay, last but not least, the trim ring. The trim ring is decorative and functional piece that sits between the main housing and the base. Uh, so, how I did it is I used the revolve tool here by sketching a small rectangular cross section at a specific distance from a center axis. I revolve it 360 degree to create a perfect ring. I then apply the very small fillet. Yes, I applied a very small fillet, 0.5 millimeter to the edges to remove the sharp cat look and make it look like a real plastic molded part. In the assembly, I used a tangent constraint. I believe it's a center axis mat to make sure it stays flush against the outer wall of the mat. Next is the cable entry. The cable entry acts as the strain relief for the unit. This was a more complex geometry. I utilized the sweep tools for this part. I sketched a circular profile and a curved path, then swept the profile along that path to create a 90-degree bend. I also used work plans to ensure the entry point aligned perfectly with the hole in the main body. That's all. The next thing is the plug. How I made it is the plug is a standard UK style 3-pin headed. I modeled the main body as a single extrusion and the pin as separate features. The tools and technique that I use is the chamfer tool on the tip of the pin for a realistic finish. To add a technical detail, I use the emboss tool to engrave safety ratings onto the face of the plug, which is a great way to add realism to a cat model.
This is the technical drawing for the spool. It features a cylindrical design with a height of 15.00 units and outer diameter of 10.00 units. The top of edge includes a 2.00 radius fillet for a smooth. This is the technical drawing for the lock switch. It has a total length of 34.00 units and a width of 9.00 units. The design features a rounded top profile with a 2.00 radius for a smooth.
So this is the exploded view for the extension. And this is the extension assembly with parts. So I will explain for the exploded view. The exploded view describes assemblies by moving components out from the assembled position. It can also used to balloon an assembly using item numbers found in parts list or bill of material. The exploded view is created by using a combination of assembly, IAM, presentation, IPN, and drawing, IDW, DWG files. A view of assembly is created in a presentation file and the components are repositioned in the view. Drawing view are then generated from the presentation file. So, in conclusion, we learned how to design 3D mechanical parts using Autodesk Inventor. We also learned the basic of computer-aided design and design drawing schematics of a product. We hope to use the skills that we learn in the future, where the skills are